Good morning, and let's discuss doubles and integers. Now, as you hopefully remember, doubles are numbers that can have decimal places. That's any decimal place, and then integers cannot have decimal places. Both of them otherwise occupy roughly the same region of numbers. The only difference is, of course, that doubles have non-whole numbers, and integers are only whole numbers. We're going to discuss, and not in PowerPoint, thankfully, I'm just using it for drawing space. We're going to discuss how to declare and initialize, how to convert from integer to double, and then we're going to talk about how to get into an integer, how to put a double value into an integer. This one's going to be the harder one because, because that's going to be the one that requires a little more effort. So let's say I'm in a program. We're going to pretend that this little blank space here is a program. And I just have to go ahead and make a double and an integer. So I'm going to do that. Double, and we'll use X and Y. Actually, no, we should probably we're going to use DBL and I. So DBL, and I'm going to start that off at a value of 1.4. Okay, so that's what we have right there. We'll make an integer now. Integer, and we'll call it I, and set equal to 3. All right, we have our two numbers set up. Now, to start off with how to convert from one to the other, it's actually pretty easy to put an integer value into a double. All it really requires is just an equal sign. So if I did double equals I, what'll happen is, and I'm going to do my output in red, if I were to print out double at this point, that means that right now double would be equal to 3.0. Does that make sense? Because the I was 3, and when we put it into double format, we just add on the 0.0, so that way it's a, that looks like a face, that's pretty cool. But we put it on the 0.0, so that way it is a double value. And that's really about it, really, for putting integer values into a double. It's very easy, very simple. Now let's go the other way, and that way is going to actually be a lot harder. Let's say I did this, I equals double. Now this is the part that we're going to have some trouble with. And that looks a lot like a 6. Alright, this is the part that will have some issues. That right there will actually produce an error. Put that in green. The error is that double is so much larger than int, which might sound a little weird because, well, aren't they equal? I mean, we did set them equal to each other, or at least we gave double its value, so it is equal to it, but it's actually represented in a larger size. You see, in memory, and I'm going to be very brief with this one, an integer takes up 32 bits. Alright, so that means 32 ones and zeros, with the first bit being the ones place, the second bit being the twos place, and then the fours place, and then the last bit being actually negative 2 to the 32nd, and the second to last one being 2 to the 31st. Put very briefly, and the only parts you really need to understand here for now, the only parts you need to understand for now, is that an integer is 32 bits that allow it to represent whole numbers from negative 2 to the 32nd all the way up to positive 2 to the 32nd minus 1. Because we could have all ones here, and that's just a bunch of positive values altogether. Now, if we were to go ahead and talk about then what a double is a very similar setup, but it's double the size. It's 64 bits. So a double has in this double size, so even though it also represents 2 to the 32nd through 2 to the 31st, or 32nd minus 1, even though it also represents that same range of numbers, it represents all the, well, not all of them, sorry, represents a lot of the decimal, the non-whole number values in between. As such, it needs this double space. So that means that when the computer looks at it, it doesn't see 3 in this case. It sees 0, 0, 0, 0, 0, 0, 1, 1, right? For the 1's place and the 2's place. So that way it has 3, with everything else being zeros. Now it doesn't really pay attention to what's in these ones when it tries to cast it, or tries to convert. Because the thing is, all it sees is that double is this big, 64 big, and the I is that big, 32 big. So that if it's trying to, and I'm going to draw this in white, if it's trying to put I into double, well, it says, yeah, that fits just fine. There is no loss of data. There's nothing over here that's going to be lost. But if it tries to go the other way, put double into I, if we try to go the other way, it's going to look at it and say, well, wait a minute, this whole segment would be lost. It doesn't matter that that whole segment is all just zeros. The fact is, that would be lost. We would no longer have that data. So it tells you you're not allowed to do that because there would be a loss of precision. That loss of precision is where we lose that whole other segment of the number. In the computer's eyes, you're losing half of your data. So it does not allow that like this. Now we are still able to convert from the integer, from the double value into the integer. And this is where we're going to get into truncation. So I'm going to erase this last line here. And we're going to rewrite it as the correct bit of code to actually accomplish our goal. So believe it or not, it's actually going to be pretty similar. I'm still going to do I equals, and then a dbl over here for double, my variable. But in between the two of them, I'm going to have parentheses int. Because what I'm doing is I'm doing something called casting. Casting is where you are converting from one type to another with intention. So when you tell the computer this, what happens is it says, okay, well then, since I have a double value and I'm turning it into an integer, I'm going to go ahead and allow it to be an integer. I'm going to write out how that works. That would mean that I is equal to 3 yet again. Even though it always was, still, that's just what that says. I equals 3. We can cast it to an integer with that int. Okay, so what's the big difference then? Why is that so important to do? Well, it stops the programmer, and you'll notice a lot of programming languages will do things like this. It stops the programmer from making a mistake. So that way you have to choose to actually lose that precision. You have to make that choice to lose that data. Now in this case, it doesn't really seem to matter. We didn't lose anything. We went from 3.0 to 3. That's not a big difference. But let's do this. Let's say I take out this line where I change my double into 3.0. Alright, so I just have this line that says I equals integer double. Now integer double, I'm sorry, double, the DBL one, that was equal to 1.4, right? At the beginning of the program it was 1.4. So when we do this, when we say I equals the integer form of 1.4, it's going to change it from 1.4 into just 1. Now you might say, okay, it's rounding down, it's rounding, and that's halfway true. It is rounding, but it's always rounding down. That means even if this was 1.8, where you would normally round up, or even just 1.5, also where you'd round up, it would still round it down to 1. Because what happens is, when you have a number like 1.4, and you're turning it into an integer, it truncates. Truncate is where it just erases everything after the decimal place and just keeps the 1. Just keeps the whole numbers. It's called truncation. Truncation is where it deletes everything after the decimal point and just keeps the whole numbers. And it happens whenever we cast from double to integer. Alright, with me so far? Good, because this next part gets a little bit tougher. Alright, part 2. we're going to look at these four things. Just multiplication, division, addition, subtraction between doubles and integers. And this time I'm going to go and take us into Dr. Java, because it's going to be a lot easier to see in an actual compiler, or IDE, really. Public static void main. We're just going to fill out our things here. A lot of us in class are still kind of learning this piece. Over time, you will have it memorized. All right, so let's go ahead and make two variables. I'll make double, so equal to 5.3. Take integer I, set equal to 3. All right, and we're ready to begin. So let's start off just first with the multiplication. There are a few things I want you to understand here. I want you to understand, be a bit easier to do that. I want you to understand what values can be stored where, or rather, I guess I should say what results can be stored where, and what results. So let's make a second variable, a second integer variable, int I2. And I'm going to say it equal to I times dbl. And I want you to go ahead and, if you're following along, compile that. If not, just go ahead and watch me compile it. And you'll notice that we get an error here. Let's go and highlight it, because it's going to be a loss of precision. Because what I was expecting was that this is going to be an integer value. The thing happening here is that int times double is a double. All right? If you multiply an integer and a double together, you get a double value. So that means 3 times 5.3 makes it a double answer, with 15.9 in particular, but it makes it a double answer, and that 15.9 cannot be stored inside of an integer. It would have to be a double. So I'm going to comment that out. So actually, I'll just erase it. But so the double has to be stored inside a double answer. If you multiply an integer and a double together, you get a double. So I have to make a second double, and then if I did that, that would be just fine. Because now I'm trying to store a double answer inside of a double. If I want to do I2, the integer, I can, but there's something I have to do first. I do have to cast it. I can either cast it like this, where I'm doing integer times integer, because this happens first. If we're doing just like, orders of operations, this happens first, and then we'll do the multiplication. So this would actually be fine. Right here. See how it compiles. Oops, let's just give it a little time. Alright, cool. Oops. Yeah, there we go. Alright, so it compiles just fine. We could have also done something like I times double and then casted it up here. Right? Because then we do I times double makes 15.9 a double answer, and then we turned it into an integer, just 15, and that could be that could be stored easily. Let's do just one more, equals int I times double. So if I did this one now, what do you think? What do you think will happen? Well, if you go and compile it, you'll see we get another error. Why? Because I is an integer, and then we cast it to an integer, and then we multiply it with a double. That right there is still int times double, because it never actually changed the double. Now, I point that out not because it wasn't obvious, more or less just because it's going to be it's on that little assessment in class. I'll put it on our test, and it's definitely going to be a question I ask you often. So I just at least want to be fair and show you it. But yeah, that's just integer times double. It's the exact same thing as the one we had before. So that's another error. But these ones are fine. As long as you do not do double, if you do double times integer, it immediately becomes a double. It's going to take it up to the higher data type, the larger data type. But if you do then cast it to an integer, it can be stored in an integer safely. All those are fine. Similar thing happens with division. We're asked about the same questions here. If I do double 2, which remember is a double, equals I times double, or I divided by double, we're okay. However, if I try to use I2, which is an integer, you'll notice it gets an error. You see, if you do integer divided by double, or double divided by integer, it results in a double as well. Hopefully that makes sense. Whether you multiply double an integer or you divide double an integer, you will get a double answer. If you want to cast it, it's the same thing as the other one. You have to cast the double part of it. You can divide integer and double. That is fine. That is a-okay. But you do have to cast it if you're going to try and store it into an integer variable. You can store it, if you like, into a double, just fine. Doesn't matter what order I go in. If you do any multiplication or division between two doubles, between a double and an integer, it will always result in a double. Make sense? Alright, let's look at addition and subtraction. I saved these for last because, well, you'll see. Let's say we do I2 equals I minus double. Guess what will happen? Hey, look, it's an error. Of course it is. It's another loss of precision. Because what we're doing is we're trying to take a double value away from an integer, which we can do, but then we have to store it into a double again. It's the same thing. That int double plus or int minus double or double plus int or double minus int, all of these result in a double answer. You have to use a double. If you use integer, you need to cast it first. You need to cast it before or after. Yeah. Now I do want to show you what kinds of differences are made with that. I'm going to go ahead and erase the stuff in the middle, and we're just going to keep the addition subtraction part, because this would be the easiest to show. Let's say I have I, which is 3, minus a double, which is 5.3. And actually, I'm going to change that to just, I'm going to change this one to 5 and that one to 3. Make it a little easier to see. Now, if I do this versus this, we should get two different answers. Why? Well, let's go through it. First off, let's see what those two different answers are. If I print out I2, and I print out I3, I'm going to get the answers of 1 and 2. Oops, what did I get? Oh, yeah. I do have to redeclare those, sorry. I forgot that since I deleted the declaration for I2 and I3, I had to go and declare them then. Alright, now let's go and do that. Yes, I have 2 and 1. There we are, just like I said. Let's go through Y. Alright, this right here, I'm going to do this in the comment, is I2 equals I minus dBL, right? Now I is equal to 5. dBL is equal to 3.3. Now typically that would equal just 1.7, and then we would truncate it down to 1, right? But here's what actually happens. That's what happens on this one down here. On I2, we have this. I2 equals 5 minus the integer form of 3.3, which is actually just 5 minus 3. Because when we truncate this 0.3 off and just have it be 3, it's just 5 minus 3, which equals 2. Versus where we have this one, where we do 5 minus 3.3, and we're turning it into an integer afterwards, meaning we truncate it after doing the subtraction, we get a separate answer. Thus, that's where we get I2 is 2 and I3 is 1. Alright. In class, you can ask me any questions, of course, or here on YouTube, you can comment down there below. I think I'm starting to get people who are not in my class watching the videos, so that's been exciting. Hope I can help. Let me know, and have a good one.